This is Think Out Loud on OPB. I'm Dave Miller. Back in September, the consulting firm put out a study that was funded by electricity companies that found that by 2030, the Northwest will have a roughly 9 gigawatt energy gap. The study got a lot of regional attention, and some utility companies are now arguing that they need to build new natural gas-powered plants to meet that demand. But some other people say not so fast. The think tank Sightline Institute has a new report arguing that the 9 gigawatt figure is misleading and that we can meet the region's energy needs without burning more fossil fuels. Laura Feinstein is a fellow at Sightline. She joins us now. It's great to have you on the show.
Thank you. Happy to be here.
You started your recent report with a short history lesson. Some forecasts made in the 1970s by the Washington Public Power Supply System. What were those projections?
Yeah, so the Washington Public Power Supply System, which we in retrospect call WPSS, they projected sort of explosive growth across the Northwest region. I think it was around 6 or 7 gigawatts of demand growth, and they expected sort of a steady rise of electricity demand going forward. And from that, they planned for 5 nuclear plants. They run a little over a gigawatt each output for power. To get to that total amount, and we only got one of those 5 because that demand never materialized.
Why not?
So, why didn't the demand materialize?
Yeah.
There was a bunch of things that contributed. The economics in the area changed dramatically. There was inflation and rising interest rates that sort of throttled industrial demand that was expected to explode. And then also the Northwest consumers of electricity really bought into the conservation strategies that have carried us forward in more recent times to pretty flat demand. So that explosive growth just never happened. And 4 of the nuclear plants were canceled. 2 of them ended up partially constructed. And unfortunately, this organization, which we're pronouncing WPSS, defaulted on its construction loans. They were financed by municipal bonds, and they were sold to Wall Street investors, and ratepayers are still paying for it. They've spent over $2 billion since the initial bonds were issued, and they still owe more than $500 million. Over the next 2 decades, it should be paid off.
So that's some important historical context. And you say that about 4 decades later, the Northwest finds itself in a similar situation. What do you see as the parallels, the potential parallels between then and now?
Yeah, so before we jump into that, I just want to zoom out a little bit in the larger moment we're facing right now. We've got this new war on Iran, and it's resulting in soaring gas prices, soaring oil prices. Folks are really feeling it from gasoline, but they're probably going to start feeling it with natural gas this winter. We've got a full-out assault on clean energy from our federal administration. And so Americans are on this fossil fuel roller coaster. They're stuck, and we're basically tied to price swings and political ups and downs. So the situation today isn't all that much different than it was in the 70s during the WPSS era. We've got utilities who are acting on forecasts that really feel urgent, and they could turn out to be wrong. And there's already sort of indications that these forecasts aren't on very stable foundations. So the today's debate over the new gas infrastructure for power plants sort of is it has a very similar sound to it. We've got highly uncertain demand. We don't know how many data centers are going to site in the area in the Northwest. We don't know how quickly consumers are going to transition to electric vehicles and buy heat pumps to transition their fossil fuel heating systems off of gas to electricity. So in that respect, it has some similar features to the debate from the 70s. And then at the same time, we've got these cheaper, faster alternatives out there that that could be brought to bear that utilities are not really focused on. Um,
I
so,
want to focus for a second on this
sure.
utilities funded analysis that I mentioned briefly at the beginning. It was
Yep.
released in September by this energy consultant group E3. Can you tell us
Yes.
the basics of what that study put forward? And then we can talk about the issues you have with it. But first of all, what did they say?
Okay. So first off, it's a first part of a two-part study. The second part is to be released soon, hopefully. But we're only working with the first part, which was to define the magnitude of the resource adequacy situation in the greater Northwest, which includes Oregon, Washington, Idaho, Montana, and sort of some slivers of states adjoining those four
I've
states.
got to say, just even to stop you there, it's a bigger definition of the Northwest region than we often work with or think about. Am I right that it even includes parts of Northern California?
I believe it does. In their materials, they definitely have outlined parts of Northern California. I believe it includes the northern part that Pacific Core serves electricity to.
So, I mean, it's helpful just to think about for background here. We're not just, for example, talking about Washington and Oregon. It's a much bigger Northwest slash mountainous region. But okay, so that's
Exactly.
the area.
So they defined this area, they looked at it, they said there was going to be a 9 gigawatt shortfall. Just to put 9 gigawatts in context, that's about the power demand of the state of Oregon today. So it's not small. Um, and it's the first part of this two-part study, which the first part really focused on how big the problem is or how big the gap or concerns around resource adequacy are. Just to be helpful for your listeners, resource adequacy is a fancy industry term for um, how much power is going to be needed to serve demand during the like most extreme times, like when people are demanding the most, like hottest summer days, coldest winter days, and also when something breaks, like if a power plant goes down, can we serve demand um, under those conditions? And so it's how much power the region's going to need to both meet that like extreme peak as well as a little extra for a contingency, if something breaks. Um,
What did the analysis say about how often or how likely that gap would be a problem? In other words, I mean, how many
yeah.
days out of the year we would actually be experiencing brownouts or simply not having enough electricity?
Yeah, it's a really short period. It's under a week of days that are affected by this, and for the Northwest, generally speaking, it's in the winter time. It's like the coldest winter days. Although with folks adding air conditioning increasingly in Western Washington and Western Oregon, it's the summer peaks are also starting to grow. But all right, so back to the study. The study projected this 9 gigawatt shortfall, but that was sort of misleading and a function of framing because 9 gigawatts didn't account for any resources that were already planned to be online between now and 2030. So uh, if you factor those resources in, That cuts the problem down to closer to 5.5 gigawatts. Um, and it was just one point estimate. It didn't account for a range of possibilities for how quickly electric vehicles would be adopted, how quickly consumers would electrify their homes, and how much data center, like, would there'd be a range of opportunities for data centers. Not all data centers are going to get built. So they focused on one possible scenario, um, and framed the shortcoming, the shortfall of power, with their big number, not accounting for resources already in under development. And then they've sort of teed up for the second section what types of resources they're going to be looking at, and they're omitting one key resource that really has a tremendous impact on resource adequacy, and we're calling that large load flexibility, and the ability for large loads like data centers to curtail their electricity use when the grid is stressed.
So let's talk about how that works, and that's something that that another study that was funded by a nonprofit called Grid Lab and done by a group called Sylvan Energy Analytics. That's one of the things that they focused on was how this analysis would change if data centers were, I guess, forced is the right word. Correct me if I'm wrong, but forced to turn off for a couple days a year at peak loads, say in winter. What's the model for how that would work?
Right. So Sylvan ran through several scenarios of growth for the region and found that most of the scenarios could be solved, like the resources could be built easily enough if we included a requirement for large industrial loads to provide this flexibility. And that would be for a few hours a year, asking data centers to throttle back their electricity use. You know, data centers are pretty sophisticated. And as it turns out, even though one policy intervention would be to force them, like Texas has done, to drop their electricity use during times of grid stress. Already PGE, the Portland General Electric, has a program that says, "Hey, data center, you can get onto our system faster if you agree to this," and they have subscribers. So data centers are open-minded about this. They are willing to do it, but at the same time, I suppose they don't want to be forced because, at least in Washington State, there was a bill this year that ran that was killed by the data center lobby and data center lobby that would have allowed utilities to force them to curtail their loads, and that was a very unpopular provision, which got axed out of an early version, and then the whole bill failed in the end. So, yeah, I think it's a tricky policy, but it certainly is one that would allow us to keep the lights on for other consumers and prevent brownouts and blackouts for critical facilities like hospitals and whatnot, and implement a solution that doesn't tie us to this fossil fuel roller coaster and building more gas plants in the near term.
So I want to just, first of all, remind folks, I'm talking right now with Laura Feinstein, a fellow at Sightline Institute. And so to go back to this question of building more fossil fuel infrastructure and getting more electricity from burning fossil fuels, that's something that Puget Sound Energy and other utilities are now talking about in the Northwest. But both Washington and Oregon have laws that limit the construction of new fossil fuel power plants. What would it take to get around those laws?
Right. So yes, you're right. It is tricky to build in Washington and Oregon a new natural gas plant, but it's not impossible. In Washington, there's the Clean Energy Transition Act, the 100% Clean Energy Act, has some relief valves in it that would allow utilities to build gas plants if they could prove that resource adequacy specifically is impacted. In Oregon, it's a little trickier to build a gas plant in the state, but the consumer-owned utilities, the public utilities, are it's totally legal for them to import fossil fuel generated electricity from out of state. So that's a guardrail that Oregon still needs to establish. They have guardrails for the investor-owned utilities like PGE. They are not allowed to do that, but the consumer-owned utilities are, and increasingly we're seeing that happen for some of the utilities the public utilities out in the eastern part of the state are doing that.
Let's say that a new gas power plant was built, and so some of them were built. Is there sufficient gas and pipeline capacity currently to feed them?
Yeah, so that's another part that's a real head scratcher because the region is the gas infrastructure for the region is fairly subscribed, and especially during a peak grid event. The the most recent one in 2024 demonstrated that there wasn't excess gas capacity. So if we're going to build new gas plants, we're going to build new gas pipelines as well. And, it just seems like a slippery slope to meeting our clean energy goals and our emissions reduction goals if we're going to be investing in, these major fossil fuel infrastructure components just 25 years away from when we're trying to become, independent of these types of uh, power solutions.
I want to go back to what you were saying earlier and the lessons from the 1970s and 80s when, among other things, conservation strategies and efficiency improvements really did have a big impact on the region's energy needs. How much is that still the case today? When there have already been a lot of efficiency gains, how much more can be achieved meaningfully simply by improvements in efficiency?
I mean, there's still quite a bit of low-hanging fruit out there in terms of energy efficiency. And, energy efficiency has done most of the heavy lifting in keeping the demand for the Northwest fairly flat over the past several decades. So, there's still a lot of opportunities. And then there's some other programs out there for it, sort of the smaller version of large load flexibility, asking, households and smaller businesses to shift their loads to times when the grid isn't as stressed as well. It's called demand response. Some utilities in the area are already running programs, especially aimed at industrial customers, which have, the ability to deliver power when the grid is stressed. And there's also some really common sense reforms that states can make to permit and get those transmission lines up so we can bring in cleaner generation from other states, from other areas. The transmission building process is really broken. And my colleague, Kelly Trumbull, has a new piece out about some common sense reforms that Oregon could make to remove the red tape and sort of fall in line with the other processes and make it simpler for utilities and others to build transmission lines to bring in power from out of state to address this resource adequacy problem and achieve our clean energy objectives.
And
so
just finally, we've been talking about power plants that would be connected to the grid that would power our homes and businesses and potentially data centers. But meanwhile, tech companies are also talking about and building their own power plants to power their data centers, bypassing the grid. How does that fit into this story?
Well, that's a complicated piece. It would be very difficult for a data center to be completely off grid because they are going to want to have a lot of redundancy so that they don't, when their power plant goes offline, whether it's intentional or a contingency, that they have some backup. So it's hugely expensive for them to do that. They still do need to connect to the grid, and these policies then around the grid connection do impact them. So I think there's a lot of flurry. There's a lot of speculation, and sure, some folks are buying airplane engines to power their data centers, but I don't think that when everything shakes out, that's going to be the conventional way of doing things. Or it's just a knee-jerk reaction right now to the reality that they can't get power very quickly. So, um, but yes, that is certainly is a avenue that data centers could look at, but it's hugely inefficient, and it is going to cost them a bundle, both in capital and in operating costs.
Laura Feinstein, thanks very much.
You're welcome.
Laura
Thanks, Matt.
Feinstein is a fellow at Sightline Institute.